Now we'll be considering the differentiation of a quotient or the format y is equals to u over v, understanding that u and v are functions of x. And then we are given this principle that the y dx is equals to v du dx minus u dv dx divided by b squared. This is known as quotient rule. And we have to understand that our ability to discern which rule to apply, whether quotient or product rule, is very vital when it comes to differentiation. Let's take an example. Evaluate the y dx given y is equals to 4 sine 5x divided by 5x raised to power 4. Now 4 sine 5x divided by 5x raised to power 4 is a quotient. So we say this is u and this is v. So our u is 4 sine 5x and our v is 5x raised to power 4. Now we have to evaluate the u dx and also evaluate the v dx. Okay, so let's evaluate the u dx now. We know 4 is a product. Okay, and then we have 5 cos 5x when we apply differentiation of sine a t or sine ax, and this will give us 20 cos 5x. And differentiating v now with respect to x, let's apply the first principle, the first rule of differentiating y is equals to ax raised to power n. So we have 20x raised to power 3. So let's apply our formula that says the y dx is equals to v du dx minus u dv dx divided by v squared. So what is our v? Our v is 5x raised to power 4. Du dx is 20 cos 5x. Our u is 4 sine 5x. And our dv dx is 20 x raised to power 3 divided by v squared. And our v is 5x raised to power 4 all squared. Now let's multiply out. This will give us 100x raised to power 4 plus 5x minus 80x raised to power 3 sine 5x divided by the square of 5 is 25. The square of x raised to power 4 is x raised to power 8. So let's factorize the numerator with 20x raised to power 3, and that will give us 5x plus 5x minus 4 sine 5x divided by 25x raised to power 8. Now this will give us 4 divided by 5x raised to power 5, because we are dividing 20x raised to power 3 by 25x raised to power 8, and we have in the bracket remaining 5x plus 5x minus 4 sine 5x. Now let's take another example. Let's take another example. Number 2. Given y is equals to 5x divided by 2x squared plus 4, we should evaluate the y dx. Now we can see that this is a quotient, and we have this to be u and we have this to be v, and our u is equals to 5x and our v is equals to 2x squared plus 4. Now we can differentiate. Okay, now differentiate du dx. We will have 5. Differentiate dv dx. We will have what? 4x. Then let's apply the formula of quotient rule that says dy dx is equal to v du dx minus u dv dx divided by v squared. And our v is 2x squared plus 4. Our du dx is 5 minus u, which is 5x, and our dv dx, which is 4x, divided by our v squared, that's 2x squared plus 4 all squared. Now let's simplify further the numerator. We have 10x squared plus 20 minus 20x squared divided by 2x squared plus 4 all squared. And this, we will have 20 minus 10x squared divided by 2x squared plus 4 all squared. Let's take another example. We are given the question that determine the differential coefficient of y is equal to tan ax. Now we remember that when we want to differentiate dy dx of sine ax, we have our answer to give us a cos ax, and when we want to do the same for cos ax, we have our answer to give us minus a sine ax. Very important. So let us look at the expression of tan ax. We know that tan x is equals to sine x over cos x. Therefore, tan ax is equal to sine ax divided by cos ax. Very important. So when we want to differentiate this, we can take this to be our u and this to be our v. So our u is sine ax and our v is cos ax. Therefore, our du dx, which is differentiating sine ax, we have it to give us a cos ax, and our dv dx, which is differentiating cos ax, we have it to give us minus a sine ax. Now we apply the formula of dy dx, which is equal to v du dx minus u dv dx divided by v squared. So our v is cos ax, our du dx is a cos ax minus our u, which is sine ax, and our dv dx is minus a sine ax. Everything divided by v squared, which is cos ax squared. So let's simplify further. This will give us a cos square ax plus a sine square ax divided by cos square ax. Now let's factorize the numerator by a. That's a into cos square ax plus sine square ax divided by cos square ax. Now we recall in trigonometric identities that cos square theta plus sine square theta is equal to 1. In the same vein, we can say cos square ax plus sine square ax is also equal to 1. So therefore we have a into 1 divided by cos square ax, and this will give us a over cos square ax, or rather we say it is a multiplied by 1 over cos square ax. Now, also according to the law of indices, law of trigonometric identities, we know that 1 over cos x is equals to sec x, okay, and 1 over sine x is equals to cosec x. Likewise, 1 over cot x, 1 over tan x is equals to cot x. Now 1 over cos square x is equals to sec square x. 1 over sine square x is equals to cosec square x. And 1 over tan square x is equals to cot square x. Therefore, 1 over cos square ax will be equals to sec square ax. Therefore, our dy dx that we have been evaluating since will be equals to a multiplied by sec square ax, which will be equal to a sec square ax. Therefore, if y is equal to tan ax, then dy dx is equals to a sec square ax. In the same vein, we can be asked to evaluate the integral, the derivative rather. Question number 4, evaluate the derivative of y is equals to sec ax. Sec ax. We know that sec ax is 1 over cos ax. So we can say this is u and we can say this is v. So u is equals to 1 and v is equals to cos ax. Okay, then our du dx is equal, differentiating a constant is 0, and our dv dx, that means once we differentiate cos ax, we have minus a sine ax. Therefore, we can apply the law of quotient rule. That says dy dx is equal to v du dx minus u dv dx divided by v squared. So our v is cos ax, our du dx is 0, our u is 1, and our dv dx is minus a sine ax divided by v squared, that's cos ax squared. Now if we simplify further, we know this turns to 0 and we'll be left with a sine ax divided by cos squared ax. A sine ax divided by cos ax multiplied by cos ax, and this implies a multiplied by sine ax divided by cos ax multiplied by cos ax. So 1 over cos ax. Sine over cos is tan, 1 over cos is sec. So we have a multiplied by tan ax multiplied by sec ax. So this will give us a tan ax sec ax. Therefore, if y is equals to sec ax, our dy dx is equals to a tan ax sec ax. Now, in our next video, we'll be considering more examples on quotient rule.